So in the previous video, we looked at depth first search. So make sure you check that out before watching this one. This is breadth first search. And we already discussed depth first search, where we were basically doing a recursive call, which was pushing to the call stack to recursively go through each of these chains here. And then if you're looking for a particular value, say we're looking for 6, basically it went through this chain here. And then it went through this sub chain here, and then eventually it would do this chain here. So that was depth first search, and we saw how that worked with the implementation of a tree and also the tree nodes. And so we figured out how to use that data structure in TypeScript, but then we also implemented the DFS algorithm. In this video, we want to implement the breadth first search algorithm. So as mentioned, that starts at the root here, and then it uses a queue data structure under the hood. So then it looks at the children and it cycles through those, and it tries to look for the number. Then it looks through the next children here. If you haven't seen the previous video where we actually implemented a tree, make sure you watch that, because this is the class tree node, which we're going to reuse for the BFS video that we're doing here. So basically we wanted to answer the same question as the last video, but using breadth first search. So we got this tree node, and then we've defined our tree by pointing at the root node, which has children of its own. So this 1 to 7 value here, that represents that tree we're looking at before in the diagram. And then we're looking for the target value of 6. And basically we want to return true if we find it, otherwise we want to return false. So what we can do in this algorithm, so unlike the previous algorithm where we did a recursive call by pushing to the call stack, in this one we're going to make use of the queue data structure. So basically we can have some checks as we did before. So basically if the root node equals null, we know that, nothing was found because nothing was passed. So that's just going to have the exit condition returning to false there. And then essentially what we can do is we can have a queue. So we're going to define this queue here. And if you haven't seen the queue data structure video, make sure you check that out as well. But essentially it's an array where, the last person in, or the first person in is the first person out. So it follows FIFO. And intuitively, that's just sort of similar when you had a queue at a shopping center or something like that. So if you go to the queue, you're the first one there. You'll be the first person served and the first person to leave the queue. So I'm going to initialize an empty queue, and in this time we're going to have the queue being an array of our tree nodes here, because we're going to need to put to the front of the queue the children. So to start off with, we just have the root node here. So what we can do is we can just say we can push. And we can use push rather than shift here because there's nothing already existing there. So the last element is the first element. So we can just go ahead and put the root node here. And then essentially what we want to do is we want to, and what happened here? I don't know how that happened, but basically what we want to do is we want to continue to loop through our queue, and while there's something in the queue, we want to continue sort of searching through the children and seeing if there's anything in there until there's nothing left in the queue, or we find the result. So basically, and then we're going to add to the queue while we're sort of cycling through based on the children. So basically we have this queue, and while there's a length in the queue, or while the length is greater than 0 for clarity, we can say, well, what we want to do here is we have sort of processed the root node, but we haven't processed its children. So what we want to do is we actually want to remove the current node from the queue. So, well, sorry, we want to remove the root node from the queue. And we're currently on the root node. And I'm just going to have this variable here to define the current node. And basically, we're just going to use shift. Because what shift does is shift is going to mutate the queue, and it's going to remove the first element from the queue. So for the first case, the root node has a value of 1. So you can just think of it like an array with the value 1 in it. We want to remove that because we're sort of processing that, but we still want to have a reference to the value here. And this is going to be the root node. But we keep that because we want to access the children. So 1 has the children 2 and 3. But basically what we can do here first though is we can have a check here to say if the current node has a value equal to the target, we can just return, or the target value, we can return true here. But if not, we can sort of loop through. So I'm going to do a for each child of the current node, we can get its children. We can loop through them. And basically we can push them to the queue. And if it makes it past all of that, we're just going to have a return false here. So it's possible that the current node doesn't have any children. So I'm just going to have this if check here around it. Also, you could set the children to an empty array. But essentially, if that's defined, then we'll be able to make use of it. So let's just recap what we've done here. So we've defined our tree node class. We have created our tree, which starts at the root node, starting at the 1, which has the children 2 and 3, and then 2 has children 4 and 5, and 3 has children 6 and 7. We want to look for the target value of 6 here using breadth first search, and that's going to take our tree and the target value. And then what we're going to do is we're essentially making use of the queue data structure, and that's going to take our tree nodes and process them. And we're going to start by putting our root node, so the value 1, and essentially we know that that's going to have a length to start off with. So what we want to do is we want to take that current node 1, and then we also want to shift the array. So what we're doing here is we put in the node 1. So this is, I'm just putting the value 1, but that represents the tree node 1, which has children. And then the current node is going to be equal to the tree node 1. And then the queue shifting is going to make that go to an empty array. And now 1 is not equal to the target value, but we do have children. So 1 has the children 2 and 3. So that's how it works with the breadth first search. We're looking at the children, and then we're pushing the children to the queue. So we're pushing the tree node with the value 2 and the tree node with the value 3. And we can see how that differs from the depth first search because we're sort of going across the tree rather than down on the tree. So, you know, there's still 2 elements in the tree, so we're going to go through this while loop again. So what we're going to do this time is we're going to get the current node, and 2 was added first. That's in the first spot in the array. So what we're going to do is we're going to shift it. So shift means remove the first element, and then the current node is going to be equal to 2, and then that mutates it. So there'll just be the 3 left will be on 2. 2 is not equal to the target value. So we look at its children and we add those. So 2 has the children as 4 and 5. So they get added to the queue. And then we sort of repeat the process again. So 3 gets removed from the queue. And then 6 and 7 get added because they're the children of 3. And then you sort of go to 4. 4 doesn't have any children. 5 doesn't have any children. These get shifted off. And then eventually you get to 6 here. And then you meet this condition here that, you know, the target is equal to the current node, which returns true. So let me just run this here. So I'll run this breadth first search algorithm here, and that returns true. So you can see how this differs to the depth first search. And as explained, this is better when you can see how doing that is going to be a worse time complexity if you're looking for a number down the bottom of the tree. But if you're looking for a number at the top of the tree, it might be better. So having depth first search and breadth first search, these are 2 really important algorithms to know when dealing with tree algorithms, because lots of times you can have variations of these to solve a lot of the problems. And you need some way to sort of traverse through the tree, and these are the 2 key ways. So let's actually look at some LeetCode questions that make use of some of these algorithms and tree data structures.